Okay, in this video, we're going to look at how you remove keys from a red-black tree. And in particular, we're going to be using the algorithm from Goodrich, Tamassia, and Mount's book, Data Structures and Algorithms. And in particular, we're going to do the removals that you can see in figure 10.37 and 10.38. I'm going to do those removals, but I'm going to go into a little bit more detail than they did in the book. So this is the tree that we have after the series of insertions. So that's in the other video. So if you haven't seen that video, go find it. And that will show you how insertion works, and it will produce this tree. So the first removal we're going to do is the simplest case. We're going to remove 3. And in their algorithm, the node that is to be removed is labeled with V, and its parent is X. And then there are 2 children. Any external node, so if you remember how removal in a binary search tree works, you're always removing a node that has at least one external node. And the label that they use for the external node is W, and then the label they use for the other node, which may or may not be external, is R. Okay? And then you do your removal. Now, in the case of red-black trees, if we're removing a red node, we just remove it. So that's the simplest case. And we only have to worry about restructuring the tree when we remove a black node. And we'll see the different cases for removing when a node is black. So in this case, remember that the way that their removal algorithm works is that once we have these node labelings, we remove V and we remove W and we replace V with R. So here we have the tree after the removal. Now we're going to remove 12. So the node we want to remove is V. Its parent is X. And then we label its children with W and R. Now in this case, V is black. So we're going to say V was black. And so now we're going to perform the removal. So here we have the tree after removing the node containing 12. The next thing that we do is we find our sibling and we label it Y. Okay, now since V was black, we're going to perform either a restructuring or we're going to perform a recoloring. So in this case, the sibling of R is black, and it has a red child, and we're going to label that red child Z. And so this is a case 1 removal. Case 1 removal. And the first thing that we do is we save X's color, which is red. And now we're going to restructure the subtree rooted at X, and that subtree will become the new X. So here's the portion of the tree that won't change, and when we restructure the tree rooted at X, 5 is going to become the new root of that tree, 4 will be the left child, 7 will be the right child. So if I draw that, I have 5, 4, and 7. And this is the new X. And so for case 1, what we then do is we set X to the color that X had previously. X was previously red, so the new X is going to be red. And now we set X's left and right child to black. And so 4 was already black, 7 was red, and it's now black. And then we also set R to black. Let me just put where R ended up. So this is R down here. And because it was an external node, it's already black. And so this is our tree after we remove 12. Now we're going to remove 17. 17 is a red node, so it's not going to require any restructuring. We just remove it as we would in a binary search tree. The node that we want to remove is V. Its parent is X. If it has, so it's guaranteed to have at least one external node. The external node is W. And then the other node, which could be an internal node, in this case it's external, we label it R. And now we remove V and W and we replace V with R. Here's the tree after removal. Now we're going to remove 18. It's a black node, so it's going to require some restructuring. V is the node we want to remove. X is its parent. W is an external node. R is the other child. To perform the removal, we remove V and W and replace V with R. Here's the tree after the removal of the node. And now what we do is we look at R's sibling and label our sibling Y. So in this case, the sibling Y of R is black, and both of Y's children are black. In this case, they're both external nodes, which are always black. So this is a case 2 removal. We solve this case by recoloring. So we set R to black. It already is black. We set Y to red. And since X is red, we paint it black. So here's the tree after we remove 18 and then recolor. You know, the way that you can check that you perform the operations correctly is that all external nodes should have the same black depth. So here we have 1, 2, 3. And then on the right side we have 1, 2, 3, and 1, 2, 3. So that's how you can check to make sure that you perform these operations correctly. Now we're going to remove 15. So 15 is V, the parent is X, W, and R. We erase or remove V and W and replace V with R. Here's the tree after removal, and since we removed a red node, we don't have to restructure or recolor. Now we're going to remove 16. V is the node that we want to remove. X is the parent, W and R are the children. We remove V and W, we replace V with R. Because we removed a black node, we've got to either restructure or recolor, or both really. And so Y is our sibling, and we see that the sibling of R, which is Y, is red. So this is going to be a case 3 removal or restructuring. So case 3. And so with case 3, so now we have to find Z, and Z is going to be Y's left child because Y is the left child of X. So here is Z. And now we're going to restructure, and Y is going to be the new root of the tree. And so 5 is going to be the root. 4 will be the left child. 14 will be the right child. And 7 will now be 14's left child. So now that we've restructured, Y is going to be the node 5. X is going to be the node 14. Z is 4. And R is here. And after we restructure, we set Y to black. Well, Y is black. We set X to red. And we set R to black. And so this is what we have after restructuring. And now what we need to do is we need to remedy the double black problem that still exists in the tree. So we have R, And this is a recursive call to remedy double black, or whatever you call your routine that does this. And this time we look at R, and we see that the sibling Y of R is black, and both its children are black. And so what we do is we recolor, we set R to black, we set Y to red, and since X is red, we set it to black. So here's the tree after case 3 restructuring and case 2 recoloring. Now we're going to remove 4, V, X, W, R. Here's the tree after we remove the node containing 4. We removed a black node, so we have to either recolor or restructure or both. Y is R's sibling, and we see that it is black, and we see that it has a red child, which we're going to label Z. And this is a case 1 removal or restructuring. So we're going to save X's color, which is black, and now we're going to restructure, and that is going to become the new Z. So when we restructure, 7 will be the root of the new tree, 5 will be the left child, 14 will be the right child, and then they just have external nodes. Here's X, here's R, and so now we set X's color to black, it already is. We set X's left child to black, which it was previously, and we set X's right child to black, it was also previously black, and then we set R to black, and it's black by virtue of the fact that it's. And here is the tree after removing 4. Now we're going to remove 7, and what we're going to do here is we find the node to remove, which is V, W, R, and X, and we promote 14 to the node containing 7. Here's the tree after that promotion, and now we can remove V and W, and we replace V with R. Here we have the tree after removal. Because we removed a black node, we look at our sibling. Our sibling is black, and both of its children are black. So this is a case 2. And what we do in case 2 is we set R to black. It already is. We set Y to red. X is not red, and X has no parent. So we stop, and here's the tree after removing 7. Now we're going to remove 14. 14 does not have a minimum key in its right subtree, so we're going to use the maximum key from its left subtree, which is 5. So we're going to promote 5. And here's our labeling. We have V, X, W, and R. We removed a black node, so we look at our sibling. It is black. V was red, and so we paint R black. It already was black, and now this is the tree we're left with. Finally, we remove 5, and of course this is a special case, and we end up with an empty red-black tree.